Hi, I'm Chaitra. I'm a data engineering fellow at Insight. My project is called Event-Fluence, which can be used to determine the influencing power of credible tweeters. A lot of events are happening around the world, and a credible source to get details for these events is GDELT. GDELT is an open source project that monitors broadcast, print, and web news from around the globe and identifies themes, sources, locations, event types, etc. Each event information has all news links that have any mention of that event. This is a sample to explain what GDELT data looks like. This is from March 3rd, 2020, when the COVID outbreak had just started. The first link is about health officials warning about canceling vacations. The second link has information about the cruise industry being unhappy with these warnings. Both the links are related to the same event, which is the warnings by health officials to cancel vacations. And this is how we can get all news links related to a certain event from GDELT. Now going to Twitter, a lot of Twitter users tweet news links. We can collect these tweets that have linked to any of these events from GDELT. And we collect information of tweets, retweets, likes, etc. and use this to determine the influencing power of a Twitter user. So this can be used by ad companies to target their ads based on who is interested in what. One example is based on the political news links someone has tweeted, political ads can be targeted towards those tweeters and their followers to influence their votes. We could use hashtags, but sometimes multiple types of events have same hashtags and can cause confusions. But news links provide accurate information. So now moving on to the demo. This is the Event-Fluence dashboard showing analysis for March 2nd to March 9th, 2020. The first chart shows the number of tweets each day containing links to news articles. The second chart shows the number of tweets for each event type like government, the number of tweets for education, the number of tweets for business, etc. This shows the top tweeters uh, for each event type based on the number of retweets, likes, etc. And these are the top retweeted links in each event type. And the final one shows the number of tweets that contain links to articles from these websites. NY Times had a lot of their articles tweeted. That is what this shows. Moving on to pipeline architecture, we load the data from GDELT and Twitter to Amazon S3. Then prepare and clean and process the data using Apache Spark and load it to PostgreSQL. Finally, visualize the results using Tableau. So moving on to engineering challenges, this was mainly caused by the huge volume of Twitter data. 1 month of uncompressed Twitter data is around 840 GB and GDELT it is around 18 GB for a month. So in the first approach, what I did was I joined tweets with GDELT data to get tweets with news links from GDELT. The idea was that the number of tweets with news links is less. So store only those tweets in the database that actually have news links. But it took more than 15 hours. Next, I created 3 separate pipelines, one for Twitter, which took 12 hours to complete, one for events files from GDELT, which took around 15 minutes, and one for event mentions files from GDELT, which took around 25 minutes. In the next approach, I used horizontal scaling and increased the number of Spark workers from 4 to 7. And Twitter took around 8 hours, GDEL took around 8 minutes, and event mentions took around 10 minutes. Since GDEL processing time looked good, the final approach was used only on Twitter data, and the data was processed in smaller batch of 10 days instead of one whole month. So each batch of 10 days took around 1 hour to complete. So the total time to process a month's data was reduced to 3.2 hours. This is the data model for Event-Fluence and it is in 3NF normalized form. So because of a lot of joins and aggregations, UI queries were very slow. It took like more than 5 minutes. So indexes were created on status ID, URL, and columns, other columns that were used for UI. And then the queries return data in less than a couple of seconds. So this is me. I worked as a business intelligence engineer for close to 5 years. I have a master's degree in software engineering from San Jose State University, and I'm excited about data engineering because of the simple fact that data allows us to answer questions and make decisions based on data and not our gut based decisions. So there's a higher chance of success as well. And my hobbies include reading, hiking, cooking. An ideal vacation day for me would be being on the beach with a book in my hand. Thank you.